Hello. So let us solve the problem here. So we are supposed to calculate this line integral in which f is this vector field in 2 dimensions along the curve which is represented by this implicit function from this point to that point on the curve. It's clear that this point lies on this curve because if you replace the coordinates with these, it will work. The same here. If I want to sketch the graph of this curve to have a better understanding, so I would say that 4x squared plus y is equal to 4, even though it is written in an implicit form, but it is immediately clear that y is equal to 4 minus 4x squared. Yes? So of course, if you want to sketch this curve, this is a parabola with a maximum at point 4, and for x equals to plus or minus 1, y value is 0, so this means that we have these 2 points and the curve passes through this. So this is the actually parabola. It's nothing mysterious here. Minus 1, 0, and then I have 1, 0. We are supposed to calculate this integral when this trajectory is being traversed through from this point to that point. So that is the direction of my moving. Yes? Okay, so the first thing we have to do for calculating this line integral is to parameterize my curve. Okay? So usually the natural or the standard parameterization is quite good, meaning that let us take x to be t and then plug it back here and also write y in terms of t. So this implies that y is equal to 4 minus 4t squared. But of course, you should also know the domain in which t is changing. So here, if I start from this point, which is my starting point, and I traverse it in this direction, here t is 1. Why? Because when I am standing here, x is 1. When I plug it here, t is also 1. When I'm standing here, x is minus 1. When I plug it here, t is minus 1. So if I want to traverse this trajectory in this direction, then t actually goes from 1 to minus 1. Yes, because it starts from 1 to minus 1. Okay, but you can do that, by the way. So you can say that t goes from 1 to minus 1. Yes, but sometimes you can also do that. You can calculate the integral in this direction, and then whatever you get, you can multiply it by a minus sign, because there is a rule that the integral of minus gamma, I mean the trajectory which is traversed in the opposite direction of gamma. So if I ask you how these line integrals are related, there is a theorem in the book that tells you that this integral is minus this integral. So by minus gamma, as I told you, I mean the same trajectory traversed in the opposite direction. So what we can do, we can calculate this line integral on the trajectory traversed in that direction, but you have to remember at the end you have to multiply everything by minus sign. So in this case, I can say that, okay, t is in the interval from minus 1 to t, to 1. So if I write this, I am starting from this point and going in that direction. Okay, so that is x and that is t. But now let us construct this. So what is the meaning of f dot dr? This is actually the dot product between two vectors, as you learned in linear algebra. So f has two components, y and 1 minus x. dr has two components, dx and dy. If you dot product them according to the usual rule for the dot product, I take the first component and multiply it by the first component. I take the second component and multiply it by the second component and then add the results. That is the definition of the dot product, yes? But then I have to write everything in terms of t, if I want to calculate this. Okay, for y, I already know what to do. For x, I already know what to do, so I need to calculate dx and dy as well. Of course, here, x is t, so this implies that dx is also dt. And then y is this, so dy is the derivative of this function, which is minus 8t multiplied by dt. So I plug these results here, then finally I get this. F dot dr is equal to, instead of y, I put 4 minus 4t squared times dx, but dx and dt are the same. And then I have here 1 minus x, which is 1 minus t, multiplied by dy, but dy is minus 8t dt. Then I can actually factor dt out because I have dt here, dt there. So this is 4 minus 4t squared. And then here I have 1 minus t multiplied by minus 8t. So when I multiply that, it becomes minus 8t, but plus 8t squared. And a little bit more simplification. So I have 8t squared minus 4t squared. So this is just simply positive 4t squared. And then I have I have minus 8t. And then I have plus 4 dt. Okay, so if I call this integral I, so what I calculate is minus I, yes? So, okay, let me just do it like this. Let me calculate the integral from minus 1 to 1. Instead of f dot dr, I put this expression in, so it is 4t squared minus 8t plus 4 dt. But I just want to know that this is not exactly this integral, because this is traversing this trajectory from this point to that point. Whatever I got here, I multiply by minus sign at the very end. Okay, but that is a very simple integral to calculate. For example, I don't know how much do you know about even functions and odd functions. So here t is an odd function, and this interval is symmetric with respect to the origin. So you can just say that this integral vanishes. And what is left for me, these two, is an even function of t. So what I can do, I can write it from 0 to 1, but I have to multiply it by 2. So if you can employ these two, you can actually do it a little bit faster. But it doesn't, it's not that hard, so let us just calculate it normally. So if I want to calculate that, so the primitive function for this is 2 to the 3, t to the 3 divided by 3, so it is 4 over 3 t to the 3. And then here I have t to the 2 divided by 2, so it is 4t squared. And a primitive function for 4 is just 4t. So I have to run everything from minus 1 to 1. So what I do, I plug 1 in, so I will get 4 over 3 minus 4 plus 4. I replace t everywhere with 1. I also replace t everywhere with minus 1, so this becomes minus 4 over 3 minus 4 minus minus 4. And then I have to subtract these results. Yes? Okay, so here 4 and 4 are gone, so I am left with 4 over 3. So if I calculate that's 1, so I factor a minus sign, so finally it becomes positive. And if I take the common denominator, this is positive 8 times 3 is 24. Plus 4 is 28. And if I calculate that, it becomes 32 over 3. So the value of this integral is 32 over 3, but I want this integral according to what is defined in the problem. So the answer to integral I is actually minus 32 over 3 if I traverse the trajectory in the direction given in the problem. Okay? You could do the other way, you could do another thing. So for example here, my initial point is 1, my final point is minus 1, so I can keep it, but I can run t from 1 to minus 1. If I can do that, then of course you know that at the end you will not get this number, you will get the negative of that number. So that is the way of calculating. Another way to do that is to change the parameterization a little bit so that it actually goes into the correct direction. For example, what you can do you can choose x to be minus t rather than t from the beginning. Okay, but it will not affect the y value, because if I raise it to power 2, again y becomes 4 minus 4t squared. But then I can run t again from minus 1 to 1. But why this is good? Because if I put t equals to minus 1, x is 1. So for t minus 1, I am here. And then for t equals to 1, I am there. So if I choose this parameterization, I am exactly doing the right thing. I'm just going into the right direction. And then if you use this parameterization and do this calculation once more, so what you will get the correct answer minus 32/3 directly at the end. So you don't need to multiply. So it doesn't matter which way you use, all of them are actually working. Okay, I hope that this video was useful. Until the next video, be safe and goodbye. Thank you.